Okay, this next probability lecture is on conditional probability. Conditional probability is when one event depends on another event, and you would write that with this little line between, and you call, say, the probability of A given B. So you know one thing happens, and what's the probability of something else. So I'm going to read an example, and then I'm going to draw a little picture, so you may have to rewind a little bit and make sure you get up, but I don't want to write the whole thing out because it's kind of long. Two identical cookie jars are on a counter. Jar A contains 2 chocolate chip and 2 peanut butter cookies, while jar B contains 1 chocolate chip cookie. We select a cookie at random. What is the probability that it is a chocolate chip cookie? Well, at first glance, you'd think, well, there's 5 cookies, so the probability is 1/5. Well, that's not actually, 3/5, because there's 3 chocolate chip cookies. But that's not actually true, because first you're going to pick which jar you're picking out of. And once you pick the jar, then you'll see that that changes how you deal with your probabilities. So what you have is, let's say we have jar A and jar B, and we're going to draw something called a tree diagram. And the tree diagram shows us our outcomes, kind of like a Venn diagram does. It just you're picking them in order. So we start out and we either pick jar A or jar B. Okay, we have a 50-50 shot, a 1 out of 2 shot of picking either one of those jars. Now within the jars, jar A has 4 cookies in it. We've got a chocolate chip, we've got peanut butter, and we've got another chocolate chip and another peanut butter. Peanut butter. Now if we pick jar B, there's only one option. We've got a chocolate chip. So once we've picked jar A, if we kind of cover this up, if we're just looking at jar A, we have a 1 out of 4 chance of picking this cookie, a 1 out of 4 for this one, a 1 out of 4 for this one, a 1 out of 4 for this one. For jar B, we have a 100% chance, a probability of 1, of picking that cookie because it's the only one in the jar. So what we have then, we look at our probability of picking a chocolate chip cookie is actually, where you're going to use that multiplication principle. So we multiply this out, and we have 1/2 times 1/4. So we have a 1/8 chance here, and 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 a 1/2. Notice if you add all these up, that equals 1, because our probability is always going to add up to be 1 for all the events. So our probability of getting a chocolate chip cookie is going to be this here. We've got 1/8, 1/8, and 1/2, which is going to give us 3/4. 1/8 plus 1/8 plus 4/8. Remember 4, 5, 6, 6/8, which simplifies to 3/4. So our probability of getting a chocolate chip cookie is actually 3/4 because we have to pick this first. Now what happens if we want to know the probability of picking a chocolate chip cookie given that we already know we picked jar A? Well, if we've already picked jar A, we don't have to worry about all this stuff over here. We just need to deal with this section here because we already know we're on this branch of the tree. So we look here and we've got a 2/4 or 1/2 probability of picking a chocolate chip given that we have jar A. Now what about if we have chocolate chip and we know we picked jar B? Well, if we know we picked jar B, we're only looking at this branch of the tree, so we don't need to worry about the probability of picking the jar in the first place. So our probability is 1 because we know we're going to get a chocolate chip cookie if we have given that. So when you look at these different things where you're selecting multiple things, you've got to pay attention to whether you're given information that you picked something first, or whether you don't know which you've picked first.